Hi everybody, welcome to the class Optical Communication, Unit 2, Transmission Characteristics of Optical Fiber. So till now we have seen about what is attenuation, what are the three major factors that causes attenuation. Under this we have seen what is absorption loss, scattering loss and bending loss. And today we are going to see about signal dispersion. Or we can say it is a signal degradation in the optical fiber. So first let us discuss the two common definitions for that is signal attenuation and signal distortion. Signal attenuation, it determines the signal strength, unamplified or repeated-less distance between the transmitter and receiver. So from the definition you can understand, so attenuation that of course determines the signal strength over a distance. Second one is signal distortion or dispersion that causes optical. This is causes mainly due to optical pulse broadening or overlapping with neighbor pulse, creating errors in the receiver output. It limits the information carrying capacity of a fiber. So we have seen the various types of attenuation and now we are going to see the various types of signal dispersion or a signal distortion. So there are three major types: intermodal dispersion, intramodal dispersion and polarization mode dispersion. Under intramodal dispersion, we have two types. One is material dispersion and second one is waveguide dispersion. So in detail, we are going to see one by one in your following slides. Signal distortion and dispersion in fibers. Dispersion is a broadening of light pulse and is a critical factor that limits the quality of signal transmission through an optical link. The physical properties and geometry of a transmission medium are responsible for the dispersion that causes degradation in the quality of the signal as it propagates along the fiber. Depending on the origin, dispersion is broadly classified under two categories: intramodal dispersion and intermodal dispersions. So from this summary, you can understand what is dispersion. So dispersion is commonly occur due to the pulse broadening of light pulses. That will affect the information carrying capacity of your fiber. Okay, the degradation is mainly caused due to the physical properties and the geometric structure of your transmission medium. So there are two types of dispersion. Of course, there are three types, but in detail we are going to see about intramodal dispersion and intermodal dispersion. Now let us see the short definition for intramodal and intermodal dispersion. The term intramodal dispersion refers to dispersion or spreading of the pulse that occurs within a particular mode and is generally found in all types of fibers. An intermodal dispersion is caused by time delay between various modes to travel to the destination point. Single mode fibers generally suffer from special type of dispersion called polarization mode dispersion arising out of birefringence phenomena. Now let us see intersymbol interference and bandwidth. I hope this both terms are not new to you. Already you have learned in digital communication. So what is intersymbol interference? So dispersion, either it may be intramodal or intermodal, affects the transmission of optical signal in case of both analog and digital transmission of optical signal. So dispersion causes overlapping of pulse spread, making them unrealizable and resulting into intersymbol interference. This overlapping finally leads to errors in making decisions regarding ones and zeros. So when I am considering a digital transmission, a light signals will be encoded into ones and zeros. So when the pulse get broadened, it get overlapped with your neighbor pulses. So what will happen? This overlap will lead to errors in your received signal. Okay, regarding it may be ones or zeros. A large ISI may leads to increased number of errors. The error in digital optical communication is measured in terms of bit error rate, which is measured in terms of number of errors incurred in a given bit stream. So compared to analog communication, digital transmission is used nowadays. So ISI is commonly occurred in your digital transmission. So when there is a large ISI in your optical fiber, that leads to large number of errors. Okay, so this will be measured in terms of bit error rate. So ISI restricts bit rate, and a bit rate may be viewed as an analog of bandwidth in case of analog optical communication. Similarly, bit error rate and signal to noise ratio are also related to each other. The exact relationship depends on the characteristics of the channel. In order to avoid the effect of intersymbol interference, one must control the rate at which the bits are being transmitted. So in order to reduce the ISI, we have to control your bit rate. If TB is the duration of a single pulse, a conservative estimate of the maximum bit rate that can be obtained on an optical channel without overlapping of a bits as expressed as BT, that is transmission bandwidth, is less than equal to 1 divided by twice of pulse duration. Okay, that is BT is less than equal to 1 divided by 2 into TB. The above estimation is based on the assumption that spreading of the pulses due to dispersion in the channel is also TB. Thus, the optical bandwidth can be written as B is equal to 0.2, approximately we can say it is 0.2 divided by sigma hertz. In terms of bit rate, your transmission bandwidth is equal to optical bandwidth. So, a transmission bandwidth maximum is equal to twice of your optical bandwidth in case of return to zero case, where in case of non-return to zero case, your transmission bandwidth is equal to bandwidth. So these are the types of dispersion. First dispersion, that first diagram that depicts intramodal dispersion. So here there is a time delay between various modes within a single fiber. Okay, and the second diagram depicts the material dispersion, and of course third diagram depicts the waveguide dispersion. So this is your intersymbol pulse broadening that causes ISI in your fiber. Okay, first diagram, it shows the input pulse. So each pulse having a separate time, okay, time slot, that is T. Okay, the first pulse having T1 and second pulse having time T2. Okay. When a pulse starts to travel for a distance, your pulse, if the pulse get broadened, it starts to get overlap. So the second diagram, it shows indistinguishable pulse at time T2 is greater than T1. Okay, and of course third diagram shows when T3 is greater than T2, again your pulse can be indistinguishable. So this leads to ISI. Okay, so when a pulse travels for a long distance, if the pulse spreading occurs, that leads to ISI in your optical fiber. Now in detail we are going to see what is intramodal dispersion. Intramodal dispersion, also known as chromatic dispersion or group velocity dispersion, refers to pulse broadening that occurs within a mode because of the finite spectral width of the source. The delay difference may be caused within a mode by dispersive properties of the waveguide material arising from the dependence of refractive index on the wavelength of the light and also by guidance effects within the fiber structure. Okay, so intramodal dispersions, commonly we can name it as a chromatic dispersion or a group velocity dispersion. This is mainly occurred due to the time delay between the modes. Okay, so as we all know, there are two types of intramodal dispersion: waveguide dispersion and material dispersion. Waveguide dispersion is mainly due to the refractive index variations. Okay, that is the delay occurred due to the refractive index variations, and waveguide dispersion is mainly occurred due to the guidance effects within the fiber structure. Since both the types of dispersion occurs within a particular mode, they refer to intramodal dispersion. Excessive spreading of pulse may result into overflow from their allotted time slots. This in turn results in overlapping among the adjacent bits. The undesirable overlapping effect leads to ISI, that is intersymbol interference, and restrict the rate at which the data can be sent over the fiber. So I will stop here. So in today's class we have discussed what is dispersion, what are the factors that causes dispersion in your optical fiber, and what are the effects of the dispersion. So that comes under what is ISI and what is bandwidth, and we have seen the types of dispersion, what is intramodal dispersion and intermodal dispersion. Okay, and just we have seen the introduction about what is intramodal dispersion. In next class in detail we have seen the types of the intramodal dispersion.